Hello everybody, my name is Tjeerd at Veen. I work at the ING Bankier app. I also am the author of Swift in Depth, which I will talk to you about a little. And today I want to talk to you about enums, because I think in Swift protocols get the main stage all the time, basically, I think. But enums have some really cool properties that we can use, and I want to share some tips and tricks. And I hope that at the end of the talk you will see that your enum vocabulary has been expanded a little and you can use it a bit more often. And maybe not, we'll see. So in this talk we're going to talk about optionals, because optionals are enums, or enums that are optionals. Also about how enums can give more compile time safety. How enums are algebraic data types. A little theory, but I think it's very useful. Some mutual exclusivity that you can arrange with enums. And how subclassing can bring some problems, and instead of using protocols we can use enums as well as an alternative. I also want to talk about how protocols can give you issues, and again how an enum can bring you an alternative. And then afterwards I'll have some more stuff and some surprises, such as giveaways. Okay, so the first thing is optionals. Optional is an enum itself. I think most of you already know this. What I like is that Swift gives us syntactic sugar. So instead of typing it all out, you can just use the question mark. And let's say you have a method, you want to say make a sandwich with two optional strings. You can pattern match on them quite elegantly, because both are enums. So in this case you can use a tuple to put both of the optionals in there and match on them. And Swift will actually give you some syntactic sugar as well to make this a little bit more readable, in my opinion. It's a style preference. I like this this way. We also have enums that themselves can be optional. So we have an enum inside an enum. For example, let's say we have a web store, and there is a membership, so you can get discounts. And a customer may get this special membership for the discounts. So the membership is an enum, but it's an optional. So it's an enum inside an enum. So normally if you want to get the membership, we have to unwrap the membership and match on it. And if we cannot unwrap, we can then do other things. But it's kind of cumbersome to do it this way. So what I like to do is you can combine it, again in one switch with the little question mark. And now you still only have one switch statement. But it's a little bit more readable. It's a small trick, but I do it all the time, so it's very usable. I think what's cool about enums is that they give you compile time safety. So for example, let's say you have a settings view controller, and you know exactly which rows you're going to get. So you can, so you have like a fixed type of rows in your view controller. So sometimes what I see is people like to juggle integers around, like index path row is equals 1, equals 2, equals 3. I think it's quite dangerous, because once you start working with that and you add a new case or you change a case, then yeah, stuff may break unintentionally. What I like to do is I like to introduce an enum with the integer row type and define the cases. And then you can make the enum from the row and match on that. So some benefits is that benefits are that the compiler will actually help let you know that you missed a case or if you added a case. And also what is useful is you can reorder the enum quite easily. So let's say you have a couple of rows and they follow a certain order. You can swap the case around your enum and the view controller will keep working, because you don't have to like change all the 2s to the 3s and the 3s to the 2s, etc. So I think that's quite elegant. If we would use the new case iterable protocol, we get also another benefit, which is the all cases property, which again has the count property. And then we can use that as well in our view controllers. So we get a lot of compiler help this way, because if we would add a new case or remove a case, it will know everywhere in our code. Another one, let's say we have strings we are matching on. For example, we have an extension check to see which icon we need to represent, like it's a JPEG or a bitmap. We would normally use metadata here, but just for the example, it's a bit simpler to just look at the extension. But the problem is, once you start matching on strings all the time, and especially repeatedly, you may miss a few strings or capitalization. So what I like to do is create an enum, and then create an initializer, add the string there, make sure that it's lowercase, so you always have equal matching, and you can use a couple of multiple case matches. So you can create your enum this way, and then you can also test your enum separately versus matching on strings like 3-4 times in your application. And yeah, you don't know if like half a year from now you would edit one string or something changes, like JPG becomes JPEG, you now have a sudden bug. So now you get more compile time checks again because you're matching on enum. So for example, we now use the enum case again. I'm switching on an enum that is created from the string. And if we were to check it, it will now automatically work for JPEG, JPEG, capitals, lowercase, uppercase, etc. So it's just a little thing. Whenever I see someone match on a string, in my merge request instinct, I'm almost like, oh, maybe enum is better. And not always, but often it tends to be. And enums are actually quite interesting because they're algebraic data types. And you may see this sometimes online about product types and sum types. And I want to talk to you a little about this, because I think understanding this little bit of theory will help you reason a bit better about enums and how you can model your data. So enums are actually so-called sum types, and they're represented in different languages in different ways. And Swift uses enums to represent sum types. And people may also say, well, they're like or types, right? Like a day is either Monday or Tuesday or Wednesday. So when you have or data, you can use an enum. And if we were to look at the amount of variations that an enum can be, we can basically count the variations. And who's better to help us count than the count? And there are 7 variations in this enum. So let's take this one step further. On the other end of the spectrum, we have product types. So a product type could be a struct or a tuple. And you can think of a product type as an AND type. So for example, this Boolean container has 2 bools. And basically it has a first bool and a second bool. And I don't know if anyone has an idea how many variations Boolean container can be. 4, yeah, correct. So that is the thing with, I can show you as well, all the 4 variations. When we are dealing with a struct, we multiply each amount of variations of each property. Or you could say it's the product of all the properties are the variations of this type. So hence the product type. And when we think about this little theory, we can think about how many variations can we have in our models. So for example, if you have a struct with like 600 strings and 200 booleans, it's kind of hard to reason about, right? Like you know, like so many variations, you cannot test them all. But if you know there are like a few variations, then you would know that you have fewer cases in which a struct could surprise you. So for example, let's say we're modeling a work day, we're representing a work, element of work, and it could be half a day or full day. And we use the day enum from before, so 7 cases. And we're using a half day or full day enum that we just introduced. And together we can have 14 different types of work days. But knowing about these kind of setups, we can also do differently. We can actually create an enum instead. So now workday is an enum, and the cases are half day and full day. And inside is an associated value, we add days. And again, it's still 14 variations, but now instead of having a struct with an enum inside, we have an enum with an enum inside the cases. So that means that when you're looking at your structs, you can maybe see if you can turn it into an enum if you would like, or the other way around. And let's take this one step further. For example, let's say you're making a payment. And one of the downsides of this type is it can be a draft. So you can make a new payment in like a payment app. And when there's something as a draft, a lot of fields become optional. And when I see a lot of optionals in a struct, I'm feeling there could be a better way to represent your data. So what I like to do is I like to find values that are mutually exclusive. So we talked about enums, how they are OR types. So this payment can be either a credit card payment or a cash payment or a draft. So when I start thinking this way, I realize, oh, there's an enum in here. And there is. So we have a payment type that we can define as an enum with 3 cases, right? It's either a cash, credit card, or a draft. And then we can put this in the struct. So it's a bit cleaner, solved a bit the case where something is both a credit card and a cash payment and a draft at the same time with some weird bugs. But we still have some optionals because we have a draft. So we can create an enum instead. So now the payment type is an enum, and we put all the values from the struct inside the enum. It's a bit ugly because we have so many values in there. But what's nice about it is that only the draft has the optional properties. So the draft has the optional variations, but the other two cases are a bit more concise, more fitting for our model. But we can take one step further because we have some duplication in there. And I personally don't like it when I see like a lot of associated values inside an enum case. So what we can do is we can turn all the associated values into another struct. So for example, we have again the enum with the cases, but the duplication we replace with one struct called the payment info. So now payment info has no more optionals in there, and only the draft has a few optionals in there. Well, what I like about this is we went from a struct with an enum to an enum with a struct. And again, I think if you look at your types in your projects, you're like, oh wait, I have a struct here. I bet you can turn them into an enum and the other way around. So something to think about when you're like juggling how you want to send an API to your users. Sometimes an enum feels very nice because you get the mutually exclusive OR cases. And sometimes a struct is really nice because then you can handle properties and that sort of stuff in a better way. So another downside, I think, is when you use subclasses. I'm personally not a big fan of subclassing, and I always try to look for something else, unless it's UI kit. One of the problems I want to highlight of subclasses is how we can write ourselves into a corner and how we can solve it with an enum. So for example, let's say we're making a workout application, and the superclass has a couple of properties. And then we have run and cycle. So run and cycle inherits from the workout application and adds a few extra properties. But here's the problem. What if we add another workout that doesn't fit all the properties from the superclass? So let's say we have push-ups. With push-ups, we don't run or cycle really far. We just stay at home in the gym. And we also maybe don't need a start and end time. We can just say the dates that we did a push-up. So now we have some properties in the superclass that are not fitting for this model. So we need to do some updates, right? So what we need to do is move the properties that don't fit in push-ups back into the other two subclasses. So workout gets more simple, and then the properties go to run and cycle, so they get more complex. So basically what happens is we introduce one new subclass, and we have to refactor all the other subclasses and the superclass. And this is one reason I don't like subclasses myself. And this may not surprise you, but I would use an enum. So you can have a workout enum with the cases in here. And the nice thing is you can stick a run or cycle or any type of workout in there. And they do not also have to be classes. It could also be structs. And what I like especially that is if we have another workout, you can just add cases and everything else is intact. So you can keep adding. It doesn't matter because it's just very easy to add cases. And I think if I think about subclassing, I think like what is the real thing I want to solve? And that's I want polymorphism. Well, enums are also a way to achieve polymorphism. So something to consider. And then, oh yeah, forgot to mention, if you want to match on a workout, you have to really do all the switch cases. And I hear some people say, yeah, but I just have one workout. I don't want to match on all the workouts every time. I just want to use cycle. Well, that's okay. You can use if case let, and then you match on a single case. It's not the nicest syntax, but it does solve the case where you have only one case you want to match on. And there's another thing. We have protocols as well, of course. And they also can bring some problems once you want polymorphism. And I also want to show how enums can help here. So let's say we're making a poker game and it inherits from hashable. So any type that is a poker game is something we can stick in dictionaries and sets, etc. Now we have Stud Poker and Texas Hold'em, and they both inherit to our poker game protocol. I left the implementation out otherwise. But here's the problem. Once we want to use poker game as a dictionary key, So let's say we want to have a dictionary where the keys are, for example, the Texas Hold'em and start poker, etc., with the users in as values. Well, we can't. We're getting this error from Swift. And the reason is poker game extends from hashable. Sorry, inherits from hashable. Hashable inherits from equatable, and equatable has self-requirements. So what kind of is like a bit of hidden, I think, in Swift is that there are, in my vision, two types of protocols. You have protocols that you can use for runtime, such as keys in a dictionary and mix and matching types in arrays. And there are protocols that you can use on a compile time manner, and those are the ones with self-requirements and associated types. So once you add a self-requirement or associated type to your protocol, it's really hard to now start using them in a runtime manner. So what you usually, if you Google this, you quickly go into type erasure, and the previous speaker also mentioned. It's a very common problem. It's actually a shortcoming of Swift, I think, and you have to do some ugly workarounds. So what I recommend before making sure that you absolutely need type erasure, use enums. Enums are a concrete type. So in this case, we would have the poker game again, but now it's hashable, and it has two cases. Just like before, we can put different types inside the cases. We make sure the types are hashable, so that we automatically get all the hashable code generated for us. Thank you, Swift 4.1 and 4.2. And now, since poker game is a concrete type, we can use them as a key. And yeah, we lose a lot of benefits. You don't get protocol extension, default methods, and marking is especially much harder. But sometimes you only need a little polymorphism, and you don't always need to go just to protocols. There are more ways to achieve it. And I think enums are a nice way to do so. So these are my tips and tricks so far. There's one more enum I want you to look at, which is the result type. I like the result type a lot. Apple actually released one in their Swift package manager, so this could be like the official one that they've created. And result is a lot like optional, but instead of it being a value and nil, it has a value and an error, which is very useful for asynchronous programming, which is a whole other talk, maybe next time. So that's about it. So we talked about how enums are optionals and how we have syntactic sugar. And we talked about how optional enums can be more cleanly unwrapped using the question marks. How we have enums and that it can help you with compile time safety in your projects. And how we can use some theory about sum types and product types and how we can swap between them to model the same type of data. And how we can use the OR thinking of way to find mutually exclusive properties inside your types and abstract that away into an enum. And our subclasses give some issues and how enums can solve this. And again, also how protocols can give issues and how we can solve this. And Apple's result type is like something I would say as a little homework, check it out. And I have one shameless self-promotion here. I'm a writer of this book, Swift in Depth. It's getting quite some good ratings already. It's going to be released in print this fall, but you can get it online already. So I would like to for you to check it out. It basically tries to elevate you from an advanced beginner / intermediate level to like an expert level. So I hope you would enjoy reading it. And I have some goodies. So we have a raffle in the chat. So one person gains 4 ebooks and 1 video course. I think Bart will arrange the raffle bot in the Slack channel. And we have 3 winners who will get my book. And I have a 40% discount code on all Manning's ebooks and videos. So not just Swift books or my book, also Java, Python, C, whatever you want to learn, using the CTW CocoaHeads 18 code. I think it's active for about a month, so got to be quick. Thank you very much. Any questions?
With regards to, for example, the payment one where everything was flat.
Yeah.
Mostly in JSON responses, you would actually receive it like that.
Yeah.
Do you have some pointers how you would do that from and to conversion to from back to your enum tuples?
Well, I think I would look at what would your ideal data type look like, what you want to work with, and how far is that jump between what you get. And I would start the quick way decodable and move forward and then improve it as time permits, because you do definitely get some benefits by introducing some enums in there, because just because the backend does maybe not support some types, you may want to. And I think in the end, when I press compile, I want to get a lot of feedback of what is working, what isn't, and I think enums are a good case to make the extra effort to translate to. But do I have like an automatic way to do so? Like, no, it's more manual work. Yeah.
You're talking about manual work, so I think I know the answer. But
Yeah.
once you start going with enums, it all goes fine and nice until you add the custom case with the one associated.
Yeah, then you lose the raw value.
And then equatable breaks.
Yeah.
So do you have something for that, or is it just either code generation or manual work?
Then you have to make a manual equatable. I do know there's a sorcery plugin to generate stuff here, but I'm not sure if it works with associated types.
I think so.
Yeah. No, but that's the downside. Yeah, we have a raw value enum, and then you want to go to the associated type enum, and then you're matching all over the place. Yeah. It's true that your system becomes very rigid, right? Like the application becomes rigid with enums, but that's kind of also the point. You have a lot of checks now. All right. Anything else?
Yeah, it's not really a question. I saw stuff about enums by the point three guys, also about Algebraic types. They mentioned that NSQL session has a really weird result where some parts are optional, but you always know that they are not optional when there's no error, for instance.
Yeah.
And that they should have solved it with an enum.
Yeah.
And I think my question is, do you think they would do this at some point with the result type?
Also, the best answer I can give you is Apple has introduced the result type, but you do not automatically have it in NSQL session. Again, shameless plug, but in my book I talk to the reader about how to achieve this. You can actually, it's also not that hard. The answer is you extend URL session to use the enum, and then you can call enum result version of the same call. So it is actually, but it needs some manual work.
So when you talk about going from subclasses to enums, you talk about the advantage. Can you talk about disadvantages of this approach? So when would it be preferential to stick to subclasses?
I would rather look for other ways than subclasses in my preference, besides UI. I just got bitten too many times, and I can talk to you a long time about this. But if the downsides is you get a lot of duplication. So in subclass, you have one superclass, for example, with 5 stored properties or 10. And then the enum, you have to copy those in each case. But then, like I showed as well, you can make one smaller type and compose bigger types out of these smaller types. So the pain is not that big, I would say. And with enums, you don't get like property getter setters, like cleanup methods you can add. So you don't have that luxury. Now, that's a downside of using an enum, definitely. Good question. Yeah. All right. Thank you very much.